there are there are 14 different parts of foundry that are detailed in the first video. That is molding box, trowel, shovel, riddle, rammer, draft pipe, take-up bar, screw cutter, screw pin, flick, vent wire, roller, ladle, and crucible. There are 14 different parts detailed in the first video, and give some detailed description about the parts, Srinivas.
Yes, sir.
About first three or four different parts. Say something about molding box.
Yes, sir. Molding boxes are the boxes for which the lower part is called drag and upper part is called cope.
Sometimes
in which
sometimes we have intermediate part, intermediate component part. For an introductory session during your classes, we don't have any cheek. Okay, go ahead.
Yes, sir. In which we do castings by pouring the mold sand, and the second is trowel. Trowel is a tool used to shape and smoothen the surfaces of the mold. The next is shovel. Shovel is a tool which is used to mix the molding sand and other ingredients. And the other tool we use is riddle. Riddle is like a sieve which is used to separate other foreign materials like metal, small metal pieces, etc. And there is a rammer tool, sir, with which we compress the molding sand such that there are no gaps in the flask. And another tool is strike of bar. The strike of bar is used.
Good, seniors. Good. Very good. And what we do usually, the lower part, in the lower part, we keep the our required shape. In wooden piece, that might be a wooden piece, and we usually fill with the mold casting sand, and that was rammed now to have a close packing between the sand, and that usually lifted around. We need to keep the drag at 180 degree, and then we need to keep the upper portion of the mold at the top of the earlier mold which we kept in the lower part, and again we need to keep our cope at the top of the drag, and we need to again fill the sand. During the upper part, we need to keep the runner and riser. In order to fill the molten material, we need some provisions. We need to pour using some provision called runner, and which is usually we should have an idea over whether it was filled or not, and based on the riser, the molten metal will rise. Therefore, that was usually called as riser. And once we have filled, we have kept the upper cope in the upper part, and we were filled with the sand, and we rammed. We are closely packed the molten sand. Then what we need to do? We need to remove the mold which was kept with the tracks and copes, and then with the aid of the gap, that is provision which is present inside the drag and cope, we need to pour our molten metal, and with the aid of with the help of runner, and it was raised with the help of riser. Once the molten metal is filled with the riser, then we need to stop our pouring. And in order to during such process, there may be a external gases influence, and in order to take away the excess gases, we need to provide some poles with the aid of a wire called vent wire, and that was the process made during the foundry. And some other volunteer, please say the point which is from draw pipe to slicks. How Sundar Srinivas explained the 5 different parts. In the same way, you need to explain brass pipe, strike-up bar, screw cutter, and screw pin and slicks. Someone please.
Hello, sir. Can you hear me?
Yes.
Um, Strike off
What
bar.
is yes? What is your name?
Mukilan, sir.
Mohilan.
Mukilan. Okay.
Okay.
Yes, sir. Strike off bar. It is used to strike off the excess sand while molding, and
From
spruce.
brass pipe. You start from brass pipe.
Yes, sir. Vent wire. Vent wire. It is used to remove the excess gases which.
Brass pipe. Again. Brass pipe. What is mean by brass pipe?
No, sir. I can't hear properly. What is it?
Brass pipe. Okay, no issues. You go ahead with strike of bar.
Yeah. Yes, sir. Strike off bar, it is used to strike off the excess sand while molding, and sprue cutters produced whole after ramming the mold, and sprue pin, it is embedded in the sand and later withdrawn to produce a hole called runner.
Yes.
And
Which is used to create the 2 different parts. One is for pouring the material. The other one is for we need to know whether it was filled or not. Therefore, 2 different rods of wooden pieces are used. That is called as screw pin, and one is usually called as runner. The another one is riser. If we have the screw pin, then what is the need for the screw cutter? And do you have any doubts in that point? When we have screw pin, in addition, why we need a screw cutter? Screw cutter is, okay, I'll explain. Screw cutter.
I don't.
Then during the exit of the molten pieces, there may be dislocations of molten sand in the runner and riser portion. At that point, we need to use the screw cutter in order to make them in an appropriate place. With the aid of that tapered hole tube, we need to closely pack the molten materials. Yes, Sundar Srinivas? Yes. Okay, I'll try my level. Now check the voice is audible. Srinivas?
Sir, it's
Yes,
not
Sir,
clear, sir.
not clear,
It's
sir.
audible, but it's not clear. Slightly breaking.
Okay, no issues. Anyway we'll try. We'll try our level best. That was the uh, we'll try our level best.
Okay, sir.
Okay. In that way, the screw cutter is used to create a path that is runner and riser in a nice way. It is used to closely tie the sands which is inside the runner and riser.
Yeah.
Yes, go ahead, Muglen. Slicks.
Slicks, it is used for repairing the mold cavity. It's okay. Then.
Yes. Okay.
Then.
Good.
Okay,
So
sir.
we'll request others to explain.
Thank
The
you,
third
sir.
person.
Thank
Very
you,
good.
sir.
Very good. Anyone? Srivastava? Harsha Srivastava. Are you ready to explain? Harsha Srivastava?
sir.
Yes, Raghuram, go ahead, Raghuram.
Yes, sir. Next material is vent wire, sir. And vent wire is a thin rod or wire carrying a pointed edge at one end and a wooden handle or a loop on the other end to hold. This vent wire is used to make a path for the gases to get exit after the ramming and striking process. During the molding, during the casting of the metal or the mold, the excess gas and the steam should this creates a path for the excess gas and steams to get out. And roller is something similar to strike of bar, and it's used for surface finish of the mold. And then ladles. Ladles is the thing which is used to receive the molten metal from the melting furnace and to pour the thing into the mold. But these ladles are mostly specific for the large moldings, but and their size is designated by their metal holding capacity. Then crucibles. Crucibles are made up of refractive materials, which is similar to ladles, and this is used as a melting metal pots for small scale moldings. That's it, sir. 14 things
Very,
over.
very. And that's all about the various patterns. Second video, someone go ahead with the second video on type of patterns. And the third video, you have seen the process of making the uh, casting parts, and we'll revisit video 2, and we will visit welding. And someone please recollect the information which is disseminated in video 2, that is type of patterns. Yes, Kalyan Kumar, Puja Kalyan Kumar, go ahead.
The first pattern is called as solid pattern. It's the replica of the product in which it's either accommodated in the cope or the drag. The next is the split pattern. It's very similar to the solid pattern, but the only difference is that it's split into two halves. So the same process will be done twice. The next is the match plate pattern. In this, there is a runner and a gate system which is mounted on a wooden or metal board, which is called as a match plate. That's why it's known as the match plate pattern. And then it's arranged with the cope and drag. And this is much more easier because the mold can be withdrawn easily. The next one was the cope and drag pattern. In this pattern, two halves are mounted on individual match plates, and then there is a flask placed individually on each side of the pattern. In this pattern, the cope and drag part of the mold are prepared separately, and then they are assembled for casting. Then later on, the cope and the drag is removed, and then they are used. These patterns are usually used for heavier products. The next one is gated pattern. It's usually used in mass productions. Here, the mold cavities are formed in a single mold by joining many number of mold cavities together by using a common gate and racer system. That's why it's called as a gated pattern. And the next one is a skeleton pattern. The sixth one is a skeleton pattern. In this, a skeleton structure or a ribbed structure of wood is created for the outline of the pattern. Usually, the wood frame is filled with loam sand, and then it's rammed. Then the excess sand is removed using a strike-off bar or a stickle board. Even round shapes can be made with this. This pattern is made into two halves and then joined with glue or screws. Next is the sweep pattern. which is used for making large symmetrical mold by evolving a sweep attached to it through a spindle. One section of the pattern is rammed, and then the sweep pattern moves on to the next section. It moves section by section. This is repeated until the entire mold is completed. The final one is the shell pattern.
Segmental pattern. What about segmental pattern? Okay, no issues. You go ahead with shell pattern.
Okay, the shell pattern is used for casting hollow patterns. In this, the outer part is used for making the mold, and the inner part is used for making the core. Not sure about segmental pattern.
No issues. Very good. Very good. Very good. And we'll see the today's presentation.
Thank you, sir.
My appreciations to Sundara Srinivas, Mukilan, Raghuraman, and Pooja Kalyan Kumar. And I am expecting all 67 to give a vision over the EP. Since it was an class via MS Team, you can there is a scope for the presentation. When there is a query and when there is a chance given by us, you use that opportunity to disseminate the information which we have disseminated in the past class. Good. Anyway, good. We'll see the today's presentation, that is welding. If time feasible, we'll see fitting also. Do you have any doubts with casting?
No, sir.
Okay, fine. Yes, I have already given an insight towards welding. Welding is a joining process, and usually with the addition of heat, and usually with or without the addition of pressure. And these are some classifications of welding process. That is gas welding, resistance welding, arc welding, newer type of welding, and solid state welding. Among those, you are going to have a visit over the arc welding and gas welding. And in particular with arc welding, we are going to have a visit over the metal arc welding, and oxyacetylene welding is also available with us, and welding usually defined the collisions of metals or non-metals produced by heating materials. Either by heating or the rubbing also we can produce the metal joining. And there are a newer type of welding now came for practice, like friction stir welding, by rubbing of two different material with a minor particle, with a intermittent that is foreign particle called tool. We can have a bonding between two different materials. That is also possible. But the basic principle is the localized collision of two different materials. With the aid of heat, the bonding will happen. That is fusion of grain structure of material being welded. And as I said earlier, with or without the addition of pressure, we can do our joining process. Sometimes the filler material is added when there is a need. Usually, that is plastic, glasses, and ceramics can be made, and the welding. Two or more parts are polished at their contact surface by application of heat, pressure, and or combination of heat and pressure. And sometimes filler metal is used. See the principle. This was the principle behind the welding process, and the assemble two parts by creating fusion or a deformation in the interaction area, which is further based on the physical. You've already come across about fusion and solid state deformation. that will happen during the collision between the two different metal parts, and that will create a heat, and that will try to get elevated to the molten state and try to have a bonding between two different parts. And this is called that is fusion welding. This fusion welding, and that is high temperature phase transition will occur, and due to that, some heat affected zone is observed between two different the parts at the joining area that is affected by the heat. Therefore, it was called as heat affected zone. And this is the example for solid state welding, and these are some advanced terminologies and vocabularies or nomenclatures used in welding. And the fusion welding, solid state welding, the use of welding, there are plenty of applications we may come across the applications of welding, that is ship or bridges and roofing, or household roofing, or factory roofing, or made of the trusses are made of mild steel which is joined with the aid of welding, and machines to manufacture new products, and commercial and military aircrafts, even space programs. We have the various welding parts in automobiles, aircrafts, and airbuses, and there are various applications are available. And even the welding are not only used for joining, and it was even used for cutting also. For cutting welding, cutting can also be possible by welding. And the popular welding, as I have already detailed with the classifications itself, still oxyacetylene welding, shielded metal arc welding, gas tungsten arc welding, gas metal arc welding, flux code arc welding, and torch or oxyfuel brazing, and the information related